This is a video on quadratic expressions, and I'm just going to outline what we mean by a quadratic. Just going to get the volume right. Okay, success. So quadratic is anything with a x squared term, bx plus c. This is referred to as a monic quadratic because the coefficient of x is 1. Let's imagine the coefficient of x is not 1. That is referred to as a non-monic quadratic trinomial. Now the values of a, b, c are usually members of the integers, rational numbers, and the natural numbers, where a cannot be equal to 0. B can be equal to 0, c can be equal to 0, but if a equals 0, that turns our quadratic expression into a linear expression. And sometimes people use the term expression and equation interchangeably. Quadratic is synonymous with equation, and sometimes people mistakenly use the word equation. So we solve equations, we factorize expressions. An equation, to solve this, will be equal to 0. But we're dealing with expressions. Okay, so let's have a look at the types of quadratics we need to know. So all the quadratics here, A, B, and C, are members of the natural numbers. And the natural numbers do not include 0. So A is not equal to 0. So we've got a simple binomial expression here, binomial 2, quadratic because the power is 2. If we had something like 4x cubed minus 6x squared, this is referred to as a cubic. If we have 4x to the 4, that's quartic, quintic, and then after 5 we just use polynomial. So we've got a quadratic expression, and we need to put our expression in terms of highest common factor on the outside. Then we need to divide each term by the highest common factor. Okay, so this is basically what we're doing. Very few mathematicians write it this way. They do it by inspection, and that's how I would encourage you to do the factorizations. Now the highest common factor of 4 and 16 is 4. Highest common factor of x squared and x is x. And we can check to see if we're right by using the distributive law to multiply out. Okay, so this is called a monic trinomial. We could add quadratic in there, but that is represented in the title. So we compare this to the general form, ax squared plus bx plus c. And we have a is equal to 1, b is equal to 7, and c is equal to 12. Let's write this down again. We've got x squared plus 7x plus 12. So if a is equal to 1, in order to find the factors of 12, which add or subtract to give 7, we do AC. Because a is 1, we do 1 times 12. And look at the factors of 12, and I hope you can all see that 3 plus 4 gives 7. So we factor this. x plus 3 plus 4. And if we multiply that out, we're going to get our original quadratic. So this is a non-monic quadratic trinomial. As you can see here, a is equal to 2, b is equal to 9, and c is equal to 4. We consider AC. 2 times 4 is 8. 1 times 8 gives 9, which is our b. Okay, so a little bit different this time. Okay, so now we partition, that means break up the 9x. So we can split that 9x into 8x plus x plus 4. And if we factorize both expressions, we get 2x, x plus 4 plus 1, x plus 4. I hope you can see that we have some common terms. This is a difference of two squares. We can rewrite this as 10xy all squared minus 9 squared. And this factors nicely. This always follows the form. These are pretty easy to recognize. Sometimes though we can have something like 7a squared minus 7b squared. And you say, well hang on, 7 isn't a square number, but we can factor the 7 out, which gives us, okay, let's carry on with our factorization. Okay, so the example we are given is 100x squared y squared minus 81. We can rewrite that as 10xy all squared minus 9 all squared. That gives us 10xy minus 3, 10xy plus 3. And we can expand that out to show that we get the original expression. Okay, we're moving on quite nicely. Common factors. Sometimes when a isn't 1, we automatically go and use the grouping method to solve our non-monic. Let me give you an example. So say we get 2x squared plus 4x plus 2. We can factor out a. And that is a perfect square. Voila. Here we have a negative distributed throughout the quadratic trinomial expression. We can take the negative out. And we're left with a lovely perfect square. My favorite quadratic. Okay, so we have a perfect square here. And perfect squares are always in the form of ax plus b squared, or we could have ax minus b squared. We square the first, square the last, and we double the product. Same here, square the first, square the last, and we double the product. Okay, so this is our family of quadratics, if you like, and we need to remember binomial just means two terms. Of the binomial, we have difference of two squares, and just basic quadratics. We have monic quadratic trinomial, where a is equal to 1. We have non-monic quadratic trinomials, where a is not equal to 1. A difference of two squares, common factors, and perfect squares. And I'd encourage you to practice these so that you can recognize them in examinations.